string whose integer value is 0 mod 3. So is that a string whose integer value is 0 mod 3. Okay. So look at this. 1 minute. So if you want 0 mod 3, so string, if the alphabet is 0 and 1, it means the string is going to be a binary string, and binary string, whatever the integer value of it, if it is a multiple of 3, then you accept that string. So it is what it is. This is what it is. Okay. So for example, if this is your binary string, then this is not to be accepted. Not accepted. Okay. No, sorry, this is accepted. For example, if the binary string is 1 1, then this is to be accepted because it is 3, and 3 is multiple of 3, to be accepted. And if it is something like 1 1 0, then it is to be accepted. Then it is to be accepted. And if it is like 1 1 1, then this is not to be accepted. Not to be accepted. If you see this, this is what the integer value of it is 3, the integer value of this is 6, and integer value of this is 7, right? Okay. So when you are at any, okay, so when you are at the initial state, you have not seen anything. So the integer you can take, if you see 0 at q0, then the integer value of the string traversed so far is 0. So it will be, you can give 0 to q0, and you can say that q0 is 0 mod 2. q0 represents 0 mod 2. Okay, before I go further on constructing DFA, can you okay, before I go further on constructing DFA, let's look at the observation here. So 1 1 is a binary string, and this is accepted by DFA. This is accepted. Okay. After 1 1, you get 0, and it was accepted. And after 1 1, you get 1, and this was not accepted. And this was not accepted. Okay. And this is in the binary string. After, in the binary string, you have only two symbols, 0 or 1. So if you get, okay, just okay, so if your existing string is accepted, then if you get 0, then you will accept that whole string, but if you get 1, then you will not accept the whole string. The reason is simple. When you add a 0 to a binary string, when you add a 0 to a binary string, when you add a 0 to the binary string, when you add a 0 to the binary string, the integer value gets multiplied by 2. It's multiplied by what number? By 2n. What do you mean by that? If you see this, what is this? This is 3, and when you do this is 3, this is 6, this is 7, this is 14. Okay, this is 7, this is 14. This is 16, sorry, this is 15, what is this? 16, 24, 28, 30. So when you add a 0 to a binary string, you are multiplying it by 2, because effectively what you are doing is to perform left shift, and left shift operation gives, this in a binary string. If you perform left shift, then it will basically multiply it by 2, and when you right shift, you are dividing it by 2, right? Okay, so when you are this is 15, so what is 30? 30 is 15 into 2. This is 6, so sorry, this is 6, what is this? 3 into 2. This is 14, 14 is what? 7 into 2. So 111 was 7, when you add 0 it becomes 7 into 2. 11 was 6, sorry, 11, this 11 was 3, and when you add 0 it becomes 6. 111 was 7, when you add 0 it becomes 14. 1111 was 15, when you add 0 to it becomes 30. Okay, now what happens when it was 11, but you, okay, this is okay, take another page. So 11 was 3, what happens if I make it 111? Now this is 7. Okay, 111 was 7, if I add one more 1, then this becomes 15. 1111 was 15, if I add one more 1, then this becomes 31. So this is what? This is 3 into 2 plus 1. This is 7 into 2 plus 1. This is 15 into 2 plus 1. Right? Right. So this is what you have to understand, that if this is a binary string, whatever the integer value of it, if this is some binary string 1 0 so on so on, this, okay, if this is any binary string, this is any binary string, if you, and it has some integer value I, if you add 0 to it, then the integer value of this whole thing is going to be 2i. If this is any binary string whose integer value is I, and if you add 1 to it, then this whole integer value is 2i plus 1. Hope you get the point, right? Now we will use this fact in to construct the DFA. We will use this fact to construct the DFA. So here there is no need of n here. Sorry. So when you add a 0 to the binary string, the integer value gets multiplied by 2, right? And when you add a 1 to a binary string, the integer value gets multiplied by by 2 2i plus 1. Okay, the integer value I gets multiplied by 2i plus 1. Or not, it's not right to say gets multiplied by. Better to say the integer value becomes. The integer value becomes. Right. So what is going to be the DFA? How you will construct the DFA for it? So when you are at Q0, when you are at Q0, the remainder is 0. When you get a 1, so when the remainder would be 0? When you are at Q0, you know, when you are at Q0 means the remainder was 0. Q0 represents set of all the binary strings for which the integer value will give remainder 0 when divided by 3. Very good. Now it means what? It means that Q0 represents what? Q0 represents the integers which are 0 or 3 or 6 or 9 or 12 and so on. Then what Q1 represents? Okay. Good. And we know that because we are talking mod 3, so there is going to be 3 states representing remainder 0, representing remainder 1 and remainder 2. So Q0, when you see 1, when you are at Q0, it means this. When you are at Q0, it means the strings belongs to this group. Okay. So Q1 represents strings whose integer value will be around 1 or 4 or 7 or 10 in this group. So Q1 represents all these strings. Q0 represents these strings. Q1 represents these strings. Similarly, Q2 will be there, which will represent strings whose integer value 2, 5, 8, 11, so on. Okay. So from Q0, if you see 1, where you should go? So from Q0, if you see 1, you should go to Q1. Why? Because when you are at Q0, it means the strings that you have seen so far belongs to this group. It means it is maybe the binary string was 3 or 6 or 9. Okay, maybe it was, let's say it was 3. So it was 1 1 that you have seen so far. So you are at Q0 because of it. Now if the other string is it's the 1 that you have seen so far. That's why you are at Q0, because 1 is 3. Now if the next symbol is 1, it means that this was 3. It means that what is this number? This is 2 into 3 plus 1, which is equal to 7. 7 belongs to Q1. That's why on 1 you go to Q. Now when you are at Q1, so you have defined moves for 0 and 1. When you are at Q1, it represents these integer values 1, 4, 7, 10. Means Q1 represents all those binary strings whose integer values belongs to this group. Q1 represents all those binary strings whose integer value belongs to the group containing decimal value as 1, 4. Okay, so 1 minute. So Q1 represents all those binary strings whose decimal value belongs to one of these, 1 or 4 or 7 or 10, right? Now let's say it was 7. Let's say it was 7. Let's say that it was 7. So let's say the binary string that you have traversed so far was 111. Now because binary string you have traversed so far is 111, the next symbol can be 0 or next symbol can be 1, and you have to define move for 0 and 1. Now if the next symbol is 0, now 111 is 7, so 1110 will be 14. This 14 belongs to 2 mod 3. 14 belongs to 2 mod 3. So from Q1, if you see 14 belongs to, if you see 0, then you should go to Q2, right? Similarly, if it is 111 means 7, so 1111 means 14 plus 1 equals to 15. So from Q1, 15 is 0 mod 3. From Q1, if you see 0, if you see 1, then you should go to Q0. Okay. So we have defined, in this way we have defined moves for 0 and we have defined moves for 1. What about moves for Q2? So when you are at Q2, it means Q2 represents those binary strings whose decimal value is 2 or 5 or 8 or 11 or 14 or 17, so on. Let's say this is your, let's say if it was 1111, let's say it was 1111. Now when you are at Q2, the next symbol may be 0 or maybe 1. If it is 0, then from 1111, which was 14, if it is 0, 1110, then the next symbol is 28. 28 is what? 28 is 1 mod 3. So when you see 0, when you are at Q2 and you see 0, you go to Q1. You go to Q1. And when you are at, okay, what if the next symbol was 1? If the next symbol was 1, then this will be 28 plus 1, which is equal to 29. 29 is 2 mod 3. 29 is 2 mod 3. So at Q2, when you see 1, you stay at Q2. At Q2, when you see 1, you stay at Q2. So this is your DFA for L7. Okay. This is not confusing at all. Means I have explained this. Now I will tell you. Okay. Now I think it's the time to give you a introduction to transition graph, or transition table. So we have been seeing this is called transition diagram. Okay, this thing. So far, while we have been constructing DFAs, we have constructed DFAs using transition diagram. This is transition diagram. This is transition diagram. This is one way of representing DFA. One way of representing DFA is through transition diagram. The other way is transition table. So what is transition table? Let me